Okay, uniformly accelerated motion. I started off talking about motion by showing you displacement by dropping bean bags in a corridor every second or so and looking at the distance between those bean bags. I now want to look at what happens in the real world with the kind of motion I'd be interested in, namely free fall. If I drop an object, how does its speed increase? Now, Galileo had this problem, and he didn't have the fancy sort of electronic timers that we have today, so he had to be clever about it. And what he did is he diluted gravity. This thing that you see here is called an inclined plane. It's lower on this end than it is up there, and it's a way that we can dilute gravity. If we have an object that slides down this plane, it will travel faster and faster, just like with gravity, only it will not accelerate at the same rate. It'll accelerate slow enough that I can measure it. So now what I'm going to do is I want to just demonstrate to you that in fact this is accelerated motion, and to do that I'm going to come over here to this cart. I'm going to put it right side up so that it's in the grooves, and it slides nicely like that. And what I'm going to do, I'm going to count down from 3, and I'm going to mark with chalk each second interval, where the location is at each second interval. I'm going to start by putting a chalk mark on the table right there for 0, so that I can start marking with 1 second. So here goes: 3 Mississippi, 2 Mississippi, 1 Mississippi, 0 Mississippi, 1 Mississippi, 2 Mississippi, 2. So that's approximately where those marks are. Let's take a look at them. So the distance between these is about a span, that's about 9 inches. This one is considerably more, between 1 second and 2 seconds. That's about 2 spans. And the distance to 3, I kind of cheated a little bit and marked it prematurely. That should be about 3. So the distances between these marks, the displacement each second, is increasing linearly. That means that what we have is uniformly accelerated motion.